Hello students, welcome to the video lecture series of numerical methods in chemical engineering. We have started chapter number 2, solution of algebraic and transcendental equations. In this, first of all, we studied about the bisection method. Let us do a quick revision of all the methods. In the first method, bisection method, what is to be done? Bisection method is a bracketing method. So first of all, we have to decide the interval in which the root lies. First of all, we have to select 2 points on the x-axis A and B. The condition was f of a should be less than 0, f of b should be greater than 0, and then we were finding the approximations on basis of bisecting the interval in 2 parts. That's why it is known as bisection method. So what was the formula for that? xn is equal to a plus b by 2. Just by using this formula, we can find the different roots and we can reduce the size of the interval, right? And how we were reducing the size of the interval? If f of xn is less than 0, then the value of a is changed, and if f of xn is greater than 0, then the value of b is to be changed. So this was the fundamental, this was the basic funda. In the next method, that was Newton-Raphson method. It is open method because we are not selecting any interval, we are selecting only the initial value x0. In Newton-Raphson method, that method is known as open method. Why open method? Because we are not selecting the interval, we are selecting only a single approximation or initial approximation x0 we can say, and on the basis of x0 we have to find f of x0, f dash of x0, and on the basis of that we have to find xn plus 1. The formula for xn plus 1 was xn plus 1 is equal to xn minus f of xn upon f dash of xn. If we study that graphically, then we were drawing tangents. Tangent is a line that is touching the curve from outside, right? It is touching the curve from outside, that is known as tangent. By drawing more and more tangents, we can reach up to alpha. And we have also seen that Newton-Raphson method is the fastest method because the rate of convergence of Newton-Raphson method is 2. The third method was secant method. What is the basic difference between Newton-Raphson and secant method? Both are open method, but what is the difference? In Newton-Raphson method, we are selecting only one point x0, while in secant method, we are selecting 2 points x0 and x1. So we have to find two function values, f of x0 and f of x1. So it is little bit time consuming than Newton-Raphson method, and the rate of convergence of secant method is 1.618. Note, this is one short question that is to be asked, that can be asked, right? And graphically, what is the difference? In Newton-Raphson method, we were drawing tangents, while in secant method, we are drawing secants. Now, secant is nothing but chord. Chord is a line that is touching the curve in 2 points internally. Okay? So, this is the basic difference between Newton-Raphson and secant method. In this lecture, we are going to study the last method of this chapter, that is regular falsi method. And what is the basic difference between regular falsi and bisection? We will study the difference between regular falsi and bisection, and we will also study the difference between secant and bisection. But let us study that graphically. See, this method, if we study graphically, it is almost same as the secant method, because in this method also we have to draw the chords. See, as in all methods, this statement will be common. Let f of x0 be the given equation and y is equal to f of x be the given curve. Let us draw that x-axis, then y-axis, then curve y is equal to f of x is given. This curve is intersecting the x-axis at point alpha, so we can say alpha is the exact root of the equation. So alpha is the exact root of the equation, right? Same as the secant method, in this method also we have to take two different values. See, actually we can say this method is combination of bisection and secant method. See, if you will study graphically, then it is same as secant method, and if you will study theoretically, then it is same as the bisection method, because it is one bracketing method, right? So here you can see, okay, as it is given, we have to take one interval in which the root lies as we know that this method is bracketing method, so we have to select one interval in which the root lies. So we are considering 2 points on the curve x0 and x1. We are considering 2 points on the x-axis x0 and x1. What is the required condition? See, the required condition is same as the bisection method. The value of f of x0 should be less than 0 and the value of f of x1 should be greater than 0. Okay, so here we can see this is our x0. F of x0 is given, f of x0 is negative, so we have shown here. This is our x1, then f of x1 is positive. So our root lies in this interval x0, x1. Okay, and by extending the points x0 to the curve and x1 to the curve, we get 2 points on the curve, that is point P x0, f of x0 and point Q. And point Q x1, f of x1. Fine. So this is about the basic diagram of the regular Falsy method. It is almost similar to the secant method. It is a required condition f of x0 should be less than 0 and f of x1 should be greater than 0. Okay. What is the next step? See, we have to again draw a chord PQ that is touching the 2 points P and Q. And it will intersect the x-axis at point M, and the coordinates of point M will be, I can write the coordinates of point M, x2, 0. Okay, so these are the coordinates of point M because it is located on the x-axis, so y coordinate will be 0 and the coordinates will be x2, 0. Then I am not showing the whole method to derive the formula. We have to just remember this. See, this formula is nothing but it is same as the formula of xn plus 1 that was given for solving the numericals, right? Xn plus 1 is equal to a into f of b minus b into f of a upon f of b minus f of a. There is no need to remember this formula. You have to just replace a by x0 and b by x1. Okay, so this is our formula. Here we can find the equation for x2, that is x2 is equal to x0 into f of x1 minus x1 into f of x0 divided by f of x1 minus f of x0. So here by drawing one chord we can get the equation for x2. Now what is our next step? See, the next step is similar to the bisection method. What we have to do, we have to find f of x2, and on the basis of f of x2 we have to decide whether our root lies in which interval. Okay, see, there are two conditions possible. If f of x2 is less than 0, then we have to consider the interval like this. We have to decide the interval in which our root lies. So there are two possibilities, either f of x2 can be less than 0 or f of x2 can be greater than 0. If my f of x2 is less than 0, then we can say our root lies in the interval x2, x1, because we have to reduce the interval from left hand side because f of x2 is less than 0. So instead of x0 we have to take x2. Okay, so our interval will be x2, x1. So here you can see this is my x2. Okay, this is my x2, 0. So f of x2 will be here. So f of x2 will be less than 0. If f of x2 is less than 0, so I can say my root lies between these two values, x2 and x1. But what if my f of x2 is greater than 0? If I am getting my x2 here, okay, if I am getting my x2 here, so my f of x2 will be located here. See, this is my x2, this is my f of x2. So we can say our root lies between x0 and x2. Is it clear? Okay, so if our f of x2 is less than 0, so we can say our root lies between x2 and x1. And if f of x2 is greater than 0, then our root lies between x0 and x2. So it is very much clear that if it is less than 0, so we have to reduce the interval from left hand side, and if it is greater than 0, so we have to reduce the interval from right hand side. Here we consider our root lies between x2 and x1. So on the basis of this, you can find the formula for x3, and by drawing the chords again and again, we can find the different approximations like x3, x4, x5, and so on the basis of the function value, right? If function value is negative, then reduce the interval from left hand side, and if function value is positive, then reduce the interval from right hand side. And by reducing the interval and drawing the chords, you can reach up to alpha. So we can say we can find the approximate root with the help of this regular Falsey method. Okay. These are some features. This method is slower than Newton-Raphson and secant method, as we know that this method is bracketing method, so it will take more time to converge, right? It is bracketing method as we are deciding the interval in which the root lies, and this method is also known as false position method. So regular Falsey or false position both are same, right? So this was about theory of regular Falsey method. In the next slide, we are going to study some numericals on the basis of the regular Falsey method, right? What is given? We have to find the real root of x log x to the base 10 minus 1.2 equals to 0 up to 3 decimal places using false position method. So let us start. See what is given. F of x is given x log x to the base 10 minus 1.2 equals to 0. First of all, you have to select the decimal places as pi and the Kelsey, and the ratio should be radian. Then we have to find the initial values between which the root lies. So we have to find the value of x0 and x1. Okay. See, f of 0 is not defined because log 0 is infinity. F of 1 is minus 1.2. Okay, f of 2. What is the value of f of 2? See, here you have to remember to find the value of f of 2. You have to take the log. There are two log available in the Kelsey, log and ln. You have to use here log because base 10 is given. You have to remember. Okay, if you have to remember if base 10 is given, then you have to use log, and if base 10 is not given, right, base e is given, then ln, and if nothing is given, then also ln. If only log x is there, again you have to use ln. If base 10 is there, then only you have to use this log. So let us find the value of 2 log 2 minus 1.2. So that will give me minus 0.59794. Similarly, if I will find f of 3 is 0.23136. So this value is less than 0. And this value is greater than 0, so I can say my root lies between 2 and 3. Okay, in this method also you have to make a table. First will be approximation number a, b, then f of a, f of b, xn plus 1, and f of xn plus 1. So in this way we have to make a table. See, remember the formula to find xn plus 1 will be same as the secant method, a into f of b minus b into f of a upon f of b minus f of a. Here, we have to write here a, what is the value of a? 2. What is the value of b? 3. What is the value of f of a? That we have already found, right? This is the value of f of a, this is the value of f of b. Place these values, then find xn plus 1. You have to place in this formula a into f of b minus b into f of a upon f of b minus f of a. This is the formula to find xn plus 1. After finding xn plus 1, you have to find f of xn plus 1. And if f of xn plus 1 is negative, What is our next step? If f of xn plus 1 is negative, then place xn plus 1 in A. If f of xn plus 1 is positive, then place xn plus 1 in B. If you want to solve the numericals, this method is almost same to the bisection method. On the basis of f of xn plus 1, we are placing their values. If f of xn plus 1 is less than 0, then it is to be placed in A. Xn plus 1 is to be placed in A, and if f of xn plus 1 is greater than 0, then x is placed in B. And the answers are available in the xn plus 1. Okay, so here is the solution of this. You can see here, see this is my A, then B, f of A, okay, f of B, then this is my xn plus 1, and this is my f of xn plus 1. So f of xn plus 1 is negative, so what is to be done in the next approximation? See, this xn plus 1 is placed in A, and my B will be as it is. So, if I am placing xn plus 1 in A, then f of xn plus 1 is to be placed in f of A. See, this is my f of xn plus 1, and this is to be placed in f of A. And this value will be continuous because as the B is same, the f of B will be also same. Then again you have to find the value of xn plus 1. Then again f of xn plus 1. How we can find f of xn plus 1? By placing this value in the main function. Okay, again it is negative. As it is negative, so place xn plus 1 in A. Okay, and B will be as it is. By solving this, you can get the xn plus 1 value is 2.740. Here you can see 2.740, again 2.740. The value has been same up to 3 decimal places. So our answer will be 2.740. Okay, make sure that you are using log. Okay, log is to be used, not ln. If you use ln, then whole numerical will be incorrect. It will be wrong. Okay, so make sure whenever log base 10 is given, you have to use log. So in this way, we can solve the more numericals on the basis of regular Falsing method. Okay. See, this was about chapter number 2. Almost we have completed 4 methods. Okay, you have to solve more numericals from the question bank. And if you are having any type of doubt, you can contact me personally. Bye.